Hi, good morning. Good morning. Can you hear me? Hello, good morning. Can you hear me? Hi, Ismail. Good morning. Can you hear me?
Yes.
All right. So let's just wait for 5 more minutes to see if anyone will join us, and then we'll start from there. Can you see my screen?
Yeah.
All right then. All right. So you guys, welcome to today's live coding session, and this is the first live coding session of stage D, and you guys have tried getting to this stage. So I congratulate you all on getting to this stage. So we are getting almost at the end. This is like the second half, and then you have two more stages before you are able to successfully complete this internship. Today we'll be talking about the title of this stage is containers and infrastructure as a code, and today we'll be talking about one of the most widely used tools for container orchestration, which is Docker. So there are other tools also that can be used for container orchestration, but the most popular and the most widely used by individuals and both individuals and even organizations is Docker. So Docker has a wide support and it has a rich community of people that ensure that it has a rich community of people that ensure that Docker is working as expected. So, as I stated in the last LCS of the last session, I was saying that we'll try to integrate both Git actions and then um, containers into our try to integrate both Git actions and containers into our live coding session for this. for this stage. So the first thing we have to do though is to get acquainted with Docker. And once you start going through once you start going through your course content, you see a lot of different Docker commands that you can use, what Docker is used for, and how you can begin to use Docker for um, infrastructure, for code infrastructure and orchestration. In basic term, what Docker is a container platform. What we mean by container is it's a platform where you're able to bundle up all of your code together and ensure that you have um you have like a source where all of your um required tools are all present in a way. Taking into consideration that people use different operating systems, for example, just okay. Sorry for that brief. My router just went off suddenly. So um moving on. So I was trying to explain what Docker is, and it's a way to ensure that whenever you are migrating or moving from one whenever you are migrating or moving from one environment to another, you have like you have the confidence that your your development source code is exact. Because as I was stating previously, taking into the fact that, for example, people use different operating systems. So imagine when writing a code or when developing a project for the organization, it was done on a Linux operating system, for example. So a new person wants to modify that code, or a new person wants to like make some changes or add features to that code, and the person is now working on a Windows operating system. It will be a challenge, because when the code was written at first, everything was written, and we are not talking about just Python code now, for example, that are OS independent. We're talking about things like scripts, Bash script, and all of those kind of stuff. So that work primarily on Linux operating systems. So when someone wants to modify or make changes to that stuff, anyone that wants to do it must also have a Linux operating system. So that means we are trying to say that for everyone that is using Windows operating system, or for everyone that is using the Windows operating system, then okay, the screen is not showing yet. I've not started. I'm just still explaining, but let me share my screen. Okay, I believe the screen is. I believe my screen can be seen now. Okay, um, so what we are trying to say is when someone that is using a Windows operating system, for example, is trying to work on that same exact particular piece of code, it might prove a challenge because the way, the easiest thing that can cause that issue is something about routes. There's some route parts. So, for example, for most of us that use Windows, when you are using the command line terminal, you see that your router probably use um, the forward slash when you are routing. That those are the routes. But Linux use backward slash primarily. So Hello, can you guys hear me?
Yes, we can hear you now.
I see. All right, thank you. So I don't know the issue with this stuff. I think the internet provider have had some issue for the past few days. So all of these are things that you will still see in your course as you go along. I'm just trying to like give a word
You are
of
not
mouth.
sharing your screen.
All right, no problem. Let me try to fix that. Mm, apparently, it is saying I'm not the host of this meeting. Coming, give me a few minutes to try to sort this out because the network has probably taken away the host. Has taken away the host properties from my account. So let me just try to get this. Still can't share my screen. Why is that? Sorry, can you guys see the screen now?
No, not yet.
Not yet. How about now?
We can see your screen now.
So hello guys, can you hear me now? So can you please confirm if you can hear me and you can see my screen?
Yes, I can hear you and see your screen now.
All right, thank you. So hopefully this does not connect So I've tried to change the network I'm using. So hopefully it doesn't get us logged out again. But if this issue persists, probably we'll just have to reschedule and stuff like that. So the app you can see on my screen, this is called Docker Desktop. So the Docker Desktop is the Windows application that is provided by Docker for you to manage your container that you create with Docker. So as I stated previously, we have other container orchestration tool apart from Docker. Okay, let me try to see if we can get one of just search for one of them that apart from Docker, but Docker is the most popular. So in most cases, it is your standard, it's your de facto it is the de facto stuff that you see where people won't even have to other container tools. So as you can see, so these are the other on my screen. These are the other uh, alternatives to Docker. Uh, uh, as alternative to Docker exactly. So you can see Artifactory, Docker Registry, LL, even Windows itself has tried to create its own say container. There are a lot of them that to what Docker provides, but the standard has come a long way over the years, and when they are very very popular amongst users, and they have been able to showcase the fact that they can give new tools speedily. So this here is Docker Desktop, and it is the GUI part for orchestrating Docker containers. They are more than you don't only have the option of Docker Desktop. For people that are more attuned to using command line, there's also a command line tool. That's the Docker command line tool, especially for Windows. There are also command line tools that you can use. The Docker command line tool that you can use, which will help you orchestrate the containers. But the thing about Windows is Windows mostly prefers GUI. So that's why Docker created this platform that you can use to have a graphical interaction with your container. So this is Docker here. So these are the images. If you click on the images, these are the list of different images that you have. So on this page, the images page, I will explain what all of these are in a minute. So these containers, these images, volumes, all of these are just extras. So dev environment, this is in the beta stage. A Docker Scout, that's image analysis, and the learning center. So this is where you can like start learning how to use Docker and all. So if you come back to containers and images, so images in Docker, this is the backbone of what Docker is, because everything you do in Docker is you are trying to create an image. So this image is what you can do what this image is what you can share around. So the image is just like when for most of us that we are using phones, we have applications on our phone. So these applications were done somewhere and they were compiled somewhere by a creator. So what the developer does is after the developer creates his application in Java code, or if he uses Kotlin, after he creates his application, so all of this application, all of the source code for that application is bundled into an APK package. So that APK package is what he shares to every Android device and what he uploads to Google Play Store. So that is why when you go to Google Play Store and you download that APK and you install it on your device, you'll be able to use all of the code that that person has developed for that application. That's why when you use things like Xender to like that's for people that use Android. When you use things like Xender to send an APK file, when you send for people that have used senders to send an app before, you see that the extension when you send the app is .apk. So that APK file is that is where all of the application source code is bundled into. So when you install the APK file, then you are able to the code that the developer votes anywhere he wrote it in the world on his laptop will be able to run on your Android device enabled on your Android device. So that is what Docker is. So in Docker, instead of bundling into an APK, we bundle into a what? We bundle it into a Docker image. So in the Docker image, um, we bundle it into a Docker image, and the Docker image is what we can what now start sharing to people. That's what different developers. So let's say a developer in Nigeria, he writes a code and he bundles it to a Docker image, and you can host it online. So that Docker image can be picked up by another developer in in South Africa, for example, and developer in South Africa goes into that Docker image, and for that Docker image, and from that Docker image, they can what get access to whatever the developer wrote, and what continue with it and add extensions to that source code. So that is the ability that Docker gives us. So these are the list of images that I have on my PC. So, but there are a lot of images. So you can see in this place there's something called local. So you can have images on your local PC, where the images on your local PC are the images that you have created using your PC. They are still local. Nobody has access to this image, or nobody has access to this image apart from your local PC. Then we have something called hub. So Docker Hub is like the online repository for what? For is like the online repository for Docker images. In the sense that, for example, we have things like GitHub. GitHub is a Git enabled platform that allows people to store what? That allows people to store their code versioned, in the sense that you can revert the version of a GitHub and stuff like that. So with Docker Hub, you can now start versioning Docker images. With GitHub, you have a lot of things that you can keep there. You can keep any source of code, you can keep Python source code, Node.js source code, and all those kind of stuff. But in Docker Hub, the only thing that you can keep on a Docker Hub is a what? Is a Docker image. And that Docker image is what can be picked up anyone, anywhere. So on the Docker desktop, you have the local, these are the local images. You have Docker, and into Docker in case I believe I feel most of us should have a Docker Hub account. But if you don't have a Docker Hub account, if you just come in and type Docker Hub. Docker Hub is just like you going to a web hub or any other thing it is, and you can sign up. You guys can hear me if my page is not going through. Okay, so Docker Hub. So let me search for Docker Hub. So this is Docker Hub exactly. So you can see this is a container image library. So what you store here is a container image. You don't store a container on Docker Hub. You store the image, and it is a place where you see a lot of different. So you can see also in the URL, you can see this is called repository. So it is almost the same thing as GitHub, with the only difference being that you can only store what? Docker images. So I've been logged in automatically, and this is my Docker Hub. So these are the images I have on my Docker Hub, and this image can be accessed by anybody anywhere in the world, as long as they are public. Just like your GitHub code that you have stored on your GitHub can be accessed by anybody by just sharing a link. Just by sharing the link to this Docker Hub to anybody, you can see a list of different images, and anyone anywhere in the world can use these images. So that is for Docker Hub. So Docker Hub is the platform where people store their images. So even if you have an issue of say your system gets faulty or something, with Docker Hub you don't lose all of your progress, because all of those images that you have stored on Docker Hub are images that you can pull later, and then you can work with them. So that's Docker. So after you get an image on your local repository, you can now have a container that will run with that image. So the way it works is, been used to do what is then used to run a Docker container. And it takes all of the list of the things that you have put in that image and starts running it as a container. So very soon you see what's now works. So let me environment. Let me just try it. So let me just open VS Code. So now let me switch the tab I'm sharing. So I hope you guys can see the new screen now. So create something that is called a Docker image. It's created basically the same way you will create any code. Or yeah, I'm just so but it is just as the way you create have a list of and things and syntaxes and this syntaxes and guide code is working as expected. Do we have an issue on YouTube? Sorry, let me just okay. The stream was I see. He could not understand that it was a network issue on YouTube. Let me just try to like make a post on the channel. So just give me a few minutes to make this post on the channel. So in case for people that left, there are some people that left YouTube when there was a network issue. So as DevOps send. All right, so as I was saying, so just as every programming language has a list of different tools, a list of different syntax that you must follow. It's the same thing when you're creating a Docker file. So you need to, and with the way currently now we have a lot of tools that enable you that to ensure that you are working in the correct guideline. You can see you have Docker installed on your system. Do you want to install the recommended dev recommended session? So for most people that use Visual Studio Code, you are actually okay, go over the explanation of containers again. So what I was saying is that what containers are the platform where you now run your Docker images. Let's say for example, if you are familiar with what an operating system is, every laptop or every computer device, when they are created, they don't get created with an operating system. So after the creation of the hardware device, which is the physical computer that you can touch, but that physical computer that you can touch is enabled to what? Is enabled to run software applications. So after the creation of the hardware device, which is the computer, then an operating system answer. So although you have a computer that has been created, a parasitic PC, as long as it needs an operating system for it to work. System has to be installed on it. So some people can install Windows operating system. Some people can install Linux operating system. Some people can install Windows Server. So you have some people can install Chrome OS. There are a lot of operating systems that you can install on your computer. So if you look at it in that aspect, that is what a container is. So the container is that hardware and the image is the software. So once you have a Docker image, which is the software that you want to install, you now need to what? You now need to run your Docker image in a what? In a hardware. So that container is the hardware where your Docker image is going to be run. So immediately you have a what? Immediately you have a Docker image. The container now gives you the ability to make that Docker image come to life, because the Docker image is just a file. It's just an image file that you can share with anybody. That, okay, this is my Docker image, this is my Docker image, this is my Docker image. But for the Docker image to now come to life and run, then it needs a container. So that container is like the host, which is you can abstract it as the hardware that contains the image where the image is going to be run. Is that okay for an explanation already before I continue?
Yes, it is.
Lolade, can I go on? I don't know. Can other guys, can you hear me? I see. Okay, all right. So moving on, to create a Docker image is just like to create a Docker image, you create it from something called a Docker file. And as I was saying, if you are using Visual Studio Code, you are in a lot of help, because they now have extensions for most of all of this code that will ensure that you are adhering to the syntax, or the expected syntax for which you have to write your code. So to create one, so you just click on this file here called the Docker file, and to name it, you do something called Docker file. So this is a Docker file. You can see that the image, you can see this image here. I don't know if you can see it because it might be small, but this image that looks like a shark. If we go back to our Docker container, or let's say Docker hub, for example, if we go back to our Docker hub, let me share the Microsoft Edge. If we go back to our Docker hub and see the repositories, you can see that this image exactly, this is Docker. So to create a Docker file, there are a list of keywords that you need to have on that words. There are a list of keywords that you need to have, because it's just like, for example, when you want to import when you want to import a library or something. So if you want to import a library, you need to use the keyword import. If you don't use the keyword import, you cannot import the library. So that's basically the way Docker is. Like, you need to use, so the first thing we do is we specify the image that we want to use. So you can see Visual Studio Code has even suggested for me, since I wrote FR, so it knows that once you use the phone to say wonderful. So can you guys hear me now? All right, so I think I'm good. So you won't have the if there's no software installed on that system, there won't be there's no capability for us to for that system to work. So that is what the base image does. So the base image is like you saying that, okay, this is a the base image is you saying that um this is an hardware, and I want you to place I want you to place this software on that hardware. So you can list a lot of different base images. You can list Ubuntu. Ubuntu can be you can see Visual Studio Code has also started listing a lot of different Ubuntu images that we have. So when you have VS Code, all of these tools now, based on the code editor that you're using, it makes coding easier. It makes writing all of these things easier because they understand whatever it is you want to do because they are standard. So you have to be able to use them. So you can use Ubuntu, but where Docker gives us an edge is that now it doesn't necessarily have to be an operating system that can be your base image. Your base image can be a programming language, Python. Your base image can be another programming language, see something, Node. So once I say Node, something like Node.js, you see that Node.js has its images. So what Docker has tried to do, what containerization has tried to do is it has tried to take away it has abstracted away that layer of you have to specify that this is the specific operating system that you are going to use, but you have to specify that this is the particular version of the operating system that you want to use. You get all of this kind of stuff. With containerization, you are able to take away those layers of operating system issue of trying to sort out your operating system, and you can just write your code and bundle your code with the image of the source code for that project. So if your project is being written in Node.js, all you just have to do is your base image will be Node.js, and once your base image is in Node.js, what can you do? You can start once your base image is in Node.js, you can bundle all of your code into a Node.js application and deploy it. So any other person that takes that image from whatever from whatever platform or whatever operating system they are using, as long as what they are taking is a Docker image, they can run that Docker container that will contain all of your source code and will run as expected on your system. Why? Because you have taken away this issue of it has to be this operating system or that operating system. Docker is now the container orchestration tool that you are working with. So you can say from Ubuntu, one thing is Ubuntu is one of the most popular Linux operating system that people use. So Ubuntu Hello, can you guys hear me? I don't know. Can you guys hear me? I don't know if you can hear me or not. I see you can hear me. Alright, I thought I was not doing that because I had to go and get another stuff. So, apologies for the network issues, though. Hello, me again. It's been a long time I had network this terrible, so I'm actually very, very perplexed by this. Not in my power, and it's so. I offer my sincerest apologies, and hopefully we don't have this issue again because I can't even understand why the network is just terrible today. Um, with that, don't let me take much more of our time because we've not been able to achieve much, just been talking and not been able to show anything due to the network issue. So let me just end the live coding session of today, I'll just implore you guys to visit the documentation of Docker, visit Docker's documentation, and try to get acquainted with whatever it is that with what container orchestration is and how Docker works. Because next week we'll be doing, in the next live coding session, we'll be doing a bit of, there might not be a lot of explanation going on. To just be me trying to work on writing a Docker file. For example, we'll write a code, then we'll deploy the code to Docker Hub, then we'll then push that code to GitHub, and then we'll write a Git action to that. Anytime a change is made to the main branch, then it automatically Dockerizes that app and then pushes it to the Docker Hub. So we'll do this next live coding session, because what I plan to do today, creating a Docker image and all of those kind of stuff, since the network is this terrible, I doubt we'll be able to do all of that, because it takes some network to like try to download the file and do all of those kind of stuff. So um let me just leave the part of building an image, for example, and let me work with images that I have had previously. So the screen you can see now is my Docker desktop, and you can see that this is Hub. So I'm not logged into Hub. So, but these are the images I have on my local images. If I go to my, if I come here, for example, so I won't be building a new image today. Let me just come to my window and show you this stuff. So if I come here on my local system, so if I open up the terminal, I hope you guys can still hear me and see my screen, just to confirm. I hope you guys can see me and hear my screen.
Yes.
All right, no problem. So if I do something, so this, when I was talking about the Docker CLI, so this is, if you press Docker, you can see that it is recognized as a what, as a tool on the command line. So if I do Docker images, so this is a list of all the Docker images that I have on my PC, and you can see that these are the size of the images. So Docker images are, most times, they are normally large, due to the fact that there are a lot of things going on the back end that you probably don't know. So these are the images that I have. So for example, to run a Docker image, for example, this is a Docker Flask image, and I was trying to see if I can get where this Docker file is on my laptop. So if I can get this Docker, let me try to see if I can get this Docker image. So I'm trying to like explain the content of a Docker file. So at least that can work for today. So sorry, game dev. I'm trying to see if I can get those Docker files, but if I don't get them, then okay, this okay. So I think I got one. Let me just open this with code. So can you guys see my Docker screen? So this is a Docker code that I wrote some time ago um, to showcase the deployment of bundling up a Python code, a Python Flask web app actually, into a Docker container. So as I stated, this is the form. So what this form is saying is that if I click on the help, so what this is saying is that from base instructions should be written in uppercase, blah blah blah. Set the base image. So form is to set the base image of um so form is to set the base image of the Docker image. So that might sound conflicting somehow. We are saying we are creating a Docker image and then there's a base image. But what the base image does is that there's no Docker file that is actually bare, that starts from the scratch. So that's why there are a lot of Docker files that build on most Docker files that we see today, they build on things that have actually been created in the past, because there has to be like a platform for it to start working. So the base image has to be always set for every Docker file. So that is what lets the Docker container knows that this is the platform that this Docker image is meant to be run on. And then the work directory. So the work directory specifies the directory for the container. So that is whenever a container is created from this, whenever a container is created from this Docker image, this container will default is working directly to whatever directory you provide there. So this is a copy. So what this does is that it copies from your local PC to a destination. If I try to hover on this copy, so what this does is it copies files or folders from the source to the destination. So most times destination is what's inside the Docker image, and source is where inside the container. So what this does is that because you are trying to like bundle up your app, so your source code and everything, your source code, the folders you have written, all of the imports you have made, let's say you have created 5 Python files, and those files also have to be in the Docker image. So when the Docker image is running, when the Python code is running, every file that I have created also has to be there. So that's what copy does. Copy copies it. So what we do is when we use the copy command, you copy it from your local PC and you place it into the Docker image, so that wherever the Docker image is going, those files that you have copied will always be contained in that what in that Docker image. And then there's the run command. So this command is just like you saying that in the command line they are going to create, the command line has this base image. So I want you to run this in the bash or the command line for Windows users, PowerShell for Windows users. On Linux is called the bash. So I want you to run this command. So every command, everything you do after the run command uses the default what the default command line tool of the base image that you have specified. It uses the default command line tool of that base image that you have specified, and it runs this command on it. So what this is just doing is that this now just says it picks up the bash of this Python base image, and it runs the what the pip install upgrade blah blah blah. So people that use Python like programming language, you understand what pip install is. So you install all of the code that you need in this requirement.txt. After doing that, we then copy every file. So when you do dot, what dot means is that I'm in a current folder. So this folder that I'm in, copy. When you say dot, you are specifying that copy everything that is existing in this current path that this Docker file is existing in. So everything in that current path is copied into the what into the stuff, and you can CMD, this is called the entry point. So entry point is immediately, because all of this now, what this Docker file does is it creates the Docker image containing all of this, and whenever a Python container is run, the container starts running all of these commands that you have here line by line. So when a container is created from this Docker image, the first thing you need to do is that in that container it will install Python 3.9. That's the first thing it does. After installing Python 3.9, to create a folder called code, there'll be a folder called code, and this folder will be set as the working directory of that container. Then the next thing it does is that in the Docker image, it looks for requirement.txt in the Docker image, and it copies it into the container that you just created. So in the Docker image, there'll be a file called requirement.txt. It picks up that it picks up that requirement.txt from your Docker image and it pastes it into the new container, because the container is a new system. That's why you can use one Docker image to spin up more than one container. You can spin up 3, 4, 5 containers with one Docker image, because it repeats all of the process that have been stored in that Docker image. So it copies the requirement.txt file from that Docker image into the container that was just created, and then it runs this command using the bash tool, as I stated before, of the source image that is specified, copy. So immediately it has done all of these processes, you need to provide something called an entry point. So an entry point means that immediately once you are done with all of this process and the container is now started, this is the first command that you must run immediately the container is ready. You understand? So in our case, where we know that what we want to do is a Python code, so this just immediately run this Python code, cmd python blah blah blah. So this is the entry point. So you use cmd. Apart from cmd, you can also use entry points. That's another entry points, and then you put it inside what bracket. So every command, so this Python 3 will be written first. So the next command after the comma has a space attached to it. So this is just we saying Python 3 space / m flag. So this is the command to run a Python Linux app, sorry, a Python Flask app on what? on a Linux container. The base image for Docker containers are mostly Linux containers, but there are ways that you can change them to what, to Windows containers. So that is what this image file here is doing. So if we go back to our, and this will be the last thing I'll be showing today. So I'll be trying to spin up a container in my Docker, so this is a Docker image. So if I click on this Docker image, for example, you'll see add price. All of these processes are things that me I did not do. So everything, the way Docker works is that the Docker has layers. The Docker has layers, and the layers are what? All of this code, everything that I explained previously, all of these commands are the result of all of those commands are put in layers. So when the container is being created, it's created layer by layer. The first layer, the second layer, the third layer, up to the last layer and stuff like that. So if you scroll down here a little, if you see this cmd bash set, so what this is doing is, after it creates a new when it creates a new container, it goes into the bash of that container and it installs it tries to install Python or whatever base image. You can see this now. This is apt-get, blah, 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 fpath, blah, blah, blah. All of these are things that we do not specify ourselves, but this is the first layer that works on ensuring that the base image that you have specified is correct. So after this, I think you should be able to see this part. This is something that you can understand also. You can see work direct code. This is when we said that we are creating something called. So what this does is that in this in the container, it creates this work directory, and then you copy the requirement. You can see that everything that we had in this Docker file, even though this Docker file, I just looked for it somewhere on my PC. It was not this. I don't think it's the same file. The reason why I'll show you why it is not the same file, you see it now. But everything that is in this Docker file is also existing in this Docker image. You can see, but the CMD for this one is different. You can see that the CMD for this one uses Flask app index, blah, blah, blah. So this Docker image that I'm showing you was not created from this Docker file, because the CMD, the entry point for this file, uses Python 3, while the entry point for this other one here, it uses Flask as the entry point. So this was another image, but immediately I've created this Docker image, everything in that Docker file is bundled into that Docker image, and then you can use it anywhere it is that you want to use it. So if I come here, for example, now, so if you want to create a container, if I come to this container, you can create a container with you can create a container from here. You can also create a container using the Docker image, using the Docker command line tool. But I'll create a container from here for today, the next time. So what I just have to do is, from this Docker Flask image, I'll click on option. So okay, is this local or this is okay? I have to pull it because it is not on my local system. I'm looking for something that is on my local system that I can use. Okay, you can see this image now. Once I click on display, this is the run command. So this play command, what it does is that it creates it runs a new container based on that image. So based on the image that I have selected, it just runs a container. So if I click on the one, you can see that we have a container that is starting. And this container has started. This is because the Docker image is very light. So this container has started already. You can see it. And this is the result of the entry points. So a Flask app has been started in this container based on this image. So if I go here now, for example, if I go to my local host, let me see. Let me just confirm if I have that. I'm just doing it. If it works there, then I'll show it to you guys, because I'm not sure if the IP is the same. Localhost 80. 8 and 0. So let me see if this is going to work as. So this is not working because the port is not binded. The port is not binding. You can see it. But if I come to these containers, you can see that we have this container. It is running. It was started 53 seconds ago. If I come here now, you can see this is this. So if I come into inspect, see, these are the different things that you can see on the container, different details of the container. But I want us to see the something. So this is a command line in this container. I want to do something. If I do ls, you can see now that we have something called a Docker file. So this is like we having another container this container now is running on a base image of a what of Ubuntu. So if I do cat, that's why when I do something like cat docker file, it will work. Why? Because cat is a Linux command, and this container understands Linux command. But if I try to do something like dir, okay, this is also working. ls, I'm trying to look for something that is, you see, exactly, move is not found. Why was move not found? Because move is not originally a what? Move is not originally a Linux command that is understood. And you can see that in this Docker file now, see, this is the Docker file that we used to create this image. And everything, you see that copy requirement.txt, this is inside here. If I do cd dot dot, and now I do list, you see that we have something called code. So this was the code folder that was created. And then when we say work die code, so we're trying to say that, okay, after creating this container, create a new folder and enter into that folder directly, because that is where your what? That is where all of your source code is going to be. So if I can do cd back into code, and when I do ls now, we'll see all of our files. So that's what I'd like to do, a major building of a container. So this is a container. If I want to stop, so if I go back to my Visual Studio Code and just to see something, so this is so just to see. So if I do something called Docker PS, so you can see that this is the container that we have running. So Docker PS will show us all of the containers that we have running. This is the Docker PS container, 80 name is Vibrant, Kinikon, blah blah blah, and stuff like that. So due to the network issue that we've had for a while, I would have loved to like build a container from the ground up, experiment with different containers, Docker commands, and stuff like that. But our time is fast spent, and another live coding session will be happening here very, very soon. So we have to end this for today. But I implore you guys to go through your courses. Number one, after going through your courses, try to like ensure that you get familiar with at least the basic Docker command, Docker build, Docker run, Docker PS, Docker exec IT, and all of those kind of stuff. You don't even actually have to know them often. We just have to know the basic ones that you use day to day, and understand what Docker is, what container orchestration is. So by the next live coding session, we'll be integrating Git action and Docker. It will take a while, might use an hour or 30 minutes and stuff like that, just to see how what containerization is and how containerization makes everything easy. So this will also show you guys an example of what you guys did in the last, because I think I saw some people were saying they had issues with the last tag along project where they had to complete a CD tag along. So the next live coding session will shed light on what we're trying to do in that tag along project and how you can navigate things like that going forward. So is there any question that anyone would like to ask? Any question? So if there's no question, then I can take that as the end of today's live coding session. Once again, I apologize for the interruptions, and the network is now stable. Don't know why it was disrupting me so much earlier into this session. So we'll meet again in the next live coding sessions. Goodbye for now.